Hi, this is Ashik.
Hi, this is Swati.
And here we are with a new video on vaccines.
As we all are going through tough times in this pandemic situation caused by coronavirus,
The world is investing on the research for the development of vaccines to contain the coronavirus. So let's see the history and their developments till date.
as evidence says, Chinese used smallpox variolation in 1000 AD.
As per the documented history, Edward Jenner had developed vaccines for smallpox in the year 1796.
Louis Pasteur, who is a French chemist, microbiologist and a biologist, developed a vaccine for rabies in the year 1885.
By the year 1930, we had developed vaccines for polio, tetanus, TB, anthrax, rabies and many more diseases.
So guys, we'll see how the innate immune system works. Innate immune system helps in monitoring the pathogens and also acts as a first line of defense against infections. What is a pathogen? A pathogen is a disease causing microbe. So in innate immune system, many organs and tissues are involved in the mechanism like bone marrow, lymph node, spleen and skin. Bone marrow is a place where immune cells are born and constantly replenished. So these immune cells are produced as stem cells before developing as immune cells. And the lymph nodes are located throughout the body near the openings like mouth and genital areas. What this does is it stores the immune cells and deploy it during the infections. So what the spleen does? Spleen filters the pathogen outside the body when it is circulating inside the blood, like flushing out when the muscles contract and relax. The air inside the muscles will flush out the pathogen outside, like examples include vomiting and diarrhea. Then how does skin help? Skin has a epithelial layer in which it has a mucus lining. This mucus lining does not allow the pathogens to stick to the skin.
Adaptive immunity is also called as acquired immunity. So this involves specialized cells to perform specific process. So adaptive immunity helps us to gain the memory cells, which is very specific against the pathogens for the future infections. So what are antigens? Antigens are those proteins or the chemicals which are present on the pathogens which are taken up by our immune cells to trigger the immune reaction. Now during the infection by the pathogens, the APC cells are triggered. APC cells are nothing but antigen presenting cells. These cells would take up the antigens from the pathogens by eating them. This is also termed as phagocytosis. After the phagocytosis, the antigens present in the pathogens are presented onto the cell surface by the APC cells. Now the APC cells move from the bloodstream to the lymph nodes, where they present these antigens to the T cells. T cells, receiving these informations about the pathogens, immediately starts to multiply. During the multiplication, the T killer cells are produced. The T killer cells which goes and directly attacks into the pathogens. But during this process, there is a chemical information response that is called as a cytokinase which has been produced. These cytokinins help in two different stages. First stage, the cytokinins help in the production of B cells, which in turn helps in the production of the memory cells. These cytokines also help in the second stage to give a response to the other cells to invade or mount an attack on the pathogens produced. The B cells produce antibodies against the specific pathogens. After the primary infection, the memory cells are produced. Now this helps us to reduce the severity of the infections in the future by giving or mounting a much effective and stronger response against the same pathogens which can be reinfected in the future. Examples for the adaptive immunity is the measles. Once a person gets infected from a measles, he would not get a reinfection from the same virus because now the adaptive immunity has been triggered in.
Let us discuss about development of vaccine. Though it looks simple how to develop a vaccine, it is very complex. It almost takes 10 years to develop a vaccine. The costs are very astronomical and it takes $1 billion to develop a vaccine.
On the top of that, the virus are constantly mutating in new strains. Now, The examples would be your influenza virus or the flu virus. This makes it highly unpredictable to develop a proper vaccine against the virus.
There are different methods to create a vaccine, but it depends on a microbe whether it is a bacteria or virus.
Let's see the different types of vaccines. There are 4 types of vaccines. Type 1, live attenuated vaccines, where the weakened pathogens are used to create a vaccine. Examples would be influenza vaccine. The second type of vaccines would be the inactivated vaccines, where the pathogens have been inactivated using chemicals or heat. And the examples would be your polio vaccine.
Type 3 vaccine is subunit vaccine. This is developed by using a part of pathogen. Example, hepatitis B. Then type 4 vaccine is toxoid vaccine. This is developed by using inactivated toxins produced by bacteria. Example is tetanus vaccine. Smallpox was described in Sanskrit in around 300 BC.
Indigenous vaccine for rotavirus was invented by Indian scientist Maharaj Kishan Bhan. Hope you guys have liked our video,
Please do like, share, subscribe and comment.
and do hit the bell icon.
Please keep loving and learning microbiology.
Bye.
Bye.